Mm-hmm. Okay, so I'll go for it. Let's see. So x squared times to the half. Yep. Squared to minus a half times 3. Okay. Okay. Right. So for the product rule, so what you did was the first times the derivative of the second. You now do the second times the derivative of the first. Yep. So you did x squared times the derivative of the second function. And so that's what you have here so far. And you now do the second, or well, let's say the derivative of the first times the second. Mm-hmm. Yep. And so that's your final answer. And so it's, yeah. So for this example, you had to do both because this was a function within a function. So the product rule is when you have two functions multiplied by each other. Chain rule is when you have a function inside a function. Say it again, sorry. Yes. So if instead of x squared it was 4 or 5, then it would just be just be that one. So let's just hold on. See, they're using the chain and making my life difficult. Okay, so let's try. Let's go for the last one. Question D. Yep. So derivative -1. So 5 times squared. What did you leave out? And why is it -3x squared? Yes. Yeah, because it's bringing down the minus. Yeah. Yeah, so you get the same thing. And I'm not too pushed with simplifying it because you would then just use it for something. Have you done differentiating trig? So I think I would just do it separately then. So how about this? No, it's the same idea, I think. You've done exponentials. Yeah, okay. How would we do question 3? Let's do the third one. Sorry, C, yeah. Question 3C. So the point of the product rule is you don't have to do that. So that's like U and that's V. So I think I'm just doing it in the other order. Okay, go on, say it again. Minus 1. Why is it times minus 1? Because of bidmas, the minus 1 is to the power of only the second bracket. Hold on. Okay, so y is equal to u times v. What is dy dx equal to? So what is the product rule? Okay, so I'm just I call the derivatives dash, and so u dash times v. Okay, so what is u dash times v? Okay. Where is minus 1 coming from? Where is minus 2 coming from? Yeah. Yeah. Yes, but something's missing from that first derivative. Chain rule. Yes. So for the same reason that you multiply the first bracket by 1, you're multiplying this by 2 because the derivative of the bracket is 2. And you could simplify it further from there, but I'm not gonna. So, okay, what additional stuff is it asking us to do? How do we do it? Question C. Yeah. And you get your answer. Okay. And I will show you an easy peasy way to do all of this. Even simpler than that, shift dy dx. And then you just put in the thing. So bracket x minus 1, bracket 2 x plus 1. Hey, can you hear me? Okay, so on my calculator, I just put in the question. So shift integral for dy dx. X. Oh, you have the same one. Shift integral. So this button here. The integral symbol, which is just under the menu setup one. So you can see the d by dx there. Yours is the graphical one, is it? Let's see. So this is the one I was just opening. It's that long S with the 2 boxes. Do you have d by dx? Okay. And so derivative. Okay. I don't know. Absolute value. Yes. Okay, so put that equation into this calculator. And don't forget your brackets. Oops. That is the value of x that we sub in. So in this case, it's 2. Press equals and you get 7. Oh, sorry. No, it's not 7. It's to the minus 1. What did you get? Yeah, 0.12. No. I forgot to put in the minus 1. Oops. Where are we going? Where's this thing gone? Am I putting these at the end of quotient row? I am. There we go. Okay, so this will be a quicker way to do these, that you can just put them into the calculator like that. Find the grade. Yeah, how about question 5? Any way you like. Yeah, power 5. You would use your calculator? No, they didn't tell you to show. They didn't tell you to show it. Yeah, so for a more appropriate one, we would. Yep. Because so this is more of a teaching question. Shift pi over 4 for an exam question or something. There'd be a part B where you have to use that answer. Syntax error. Is it the bracket? It is the bracket. Okay. Oh no. 0.0. Yeah. No, I didn't. That's my mistake that I'm making. So it was that. Yeah. There we go. To the power of 5. Ugh. Okay. Hang on. Times. Go back. Power 5. I'm in radians. Let's see. X minus pi over 2 to the power of 5. That's times by sine 2x. And gradient of the curve. Let's take a look. So this is P2. This is 9D, I believe. Question 5. So they get an exact answer. 5 pi to the 4 over 256. 5 shift pi. Yeah, 1.902. So maybe try putting a time sign between that and sine 2x. So I'll try getting rid of my time sign and see what happens. So I get the same thing. Did you close the bracket for sine 2x? I can. 2x. You in radians? So, yeah. Oh, yeah. So I see the same thing, 0.04. But I don't know what I'm in. No, I'm in degrees. No. This is pi. You should be in radians. Yeah. Does it work now? Okay. Oh, which calculator is this? Okay, great. So now let's go to let's see. So this one, yeah, okay. So I want to do this one now. Question 4. How do we do this? Okay. Stationary point. So what will you do once you differentiate it? Okay. Okay, go on. Yeah. Okay, let's go on. Find the derivative of it. I don't believe you can. Well, I can, but I'll save the magic for the end. Yeah. So, so I really wouldn't mix them around. So, what did you do before? So you did the derivative of the first times the second, and so I would just stick to that. Hold on. How did you get 2x minus 2? Oh yeah, so it's outside, is it? Okay, yeah. Minus 2 to the 1. Yeah. No, that's not it at all, is it? So 2x minus 2. So 2x minus 2 to the 1. Yep. Yeah. Okay, so that's dy dx. And how do we find stationary points? No, that would be to verify that something is a stationary point. We have to actually find them first. So what do you know about the gradient of... Mm-hmm. Well, yeah, basically the whole thing is equal to 0. And that's what you solve. And at that point, you can try it with a calculator. Any other answers, or is there just one? Okay, x equals 2. Is that everything? Yep. So when you... Sorry? Yeah, so when you sub 2 back into the original, you get y is 0. So that's the 0.20. Just by coincidence is a 0. It's not special. Usually it's not. So two things. One, I will use my calculator for pure magic. I've just put in the question, x minus 2 squared to x plus 3. And you know how you sub something in for x? Well, in this case, I am subbing in x itself. Yeah. And then that's basically equal to 0 by default. Shift solve, and I'll just put in some value, and I should get 2. I'm getting x is a negative of a third. I'm getting x equals minus 1/3. Let's see if I get a different one as well. Shift solve. And I get 2 as well. X equals... So put in minus a third, see what you get for y. It depends on your initial value, I believe. So I'm not very familiar with the graphical one, but the solver only gives one answer. So when you do solve, you have to choose some initial value. So if you choose the initial value, let's say minus 9, that'll probably find a negative answer because it's negative. Yeah. So I don't... so the way the calculator works is it uses Newton-Raphson, a method to solve it, but you need some kind of initial value. Is there nowhere on your calculator to choose what like x0 you start with? Try that then. Try that. Or so okay, so this was the first thing, pure magic. The second way, to me, obviously, is you have a graphical calculator, so just graph it. and maximum y intersect, press right, oh no, press F6, so that's that. So it can find the roots. Oh, it can find the max and the min. There you go. So minus a third and 12.7. And 2 and 0. There we go. Great. Does it give points of inflection? Graphical cell. Ooh. This one. No, I don't know. Okay, grand. So that's the one with your calculator. That's the one I would use. Okay. Any questions there? Okay. And so, yeah, that would confirm that they are those points for you. Okay, so let's see. Yeah. So let's do this one. Question 8, exam question. And so you can see how for an exam question it's forcing you, part A, to do it the old-fashioned way. Like the non-calculator way. Old-fashioned. Yeah. Mm-hmm. Shouldn't be plus. Yeah. Yes, because the derivative of 3x is 3. That's it. And you'll notice they didn't ask for you to factorize it or fully factorize or anything. Okay, part B. Yeah. And so wherever you have an x, sub in a 2 in a bracket and get your answer. And then you can always verify it with your calculator. So you could put that whole mess into your calculator. I personally would just do the derivative of the original. So, yeah. You've gotten every possible method mark and everything. And they didn't say use your answer or show you working or anything. But at this stage, it's very little extra work. Yeah. Wow. Is that really the answer? And hang on, that can't be the answer, is it? Yeah, e to the 3. No, that's it. And because you have your graphical calculator, you can always just use the graphical calculator. Okay. So product rule, x a half or tick. Product rule, x a half or tick. How are you? Yeah. And I just noticed that they asked you for the gradient, but they never asked you for the equation of the tangent or something, where you would use the gradient and then sub in one coordinate or something. But I mean, yeah, and I'm just noticing that none of the exam questions actually ask for that, and so it might just be too much work. You know, like it seems like the obvious thing to do to extend the question, but it just seems like they kind of just leave it there. Okay, quotient rule. This time it's divided by a function divided by another function. So if it's y equals u over v, then it is u dash v minus v dash u all over v squared. And you just have to make sure you get them the right way around because there's a minus in between. The denominator. U over v. So yeah, so use that. Try the example 12. Yep. The product rule. Yep. Okay. Mm-hmm. 5. Yeah, and let's not hang on, I have the answer. 2x plus 5 on the top, 2x plus 5 times 1 minus 2x. Yeah. Okay, we could differentiate these. I'm just gonna say we're gonna be fine. We could differentiate those. Yeah, let's try question C. Mm-hmm. I believe it's 1 over x. Mm-hmm. Say it again, sorry. It's the same as log x to base e. Yeah. So yeah. They're just powers written a different way. Yeah. And I will stop there. That's it. Don't have to simplify that, because if you wanted to find the gradient at a point or something, you would just sub in some value for x. And we did C. And there's a bunch, so they did a bunch of stuff. I'm not simplifying it. How would you do question 4? I wouldn't. What would I do? Nope, because you're going to have to sub in a value. I would just use calculator. So the question we just did it wasn't numerical, it was algebraic, and so it just said find dy dx, like find the derivative, whereas this one says find the x at one specific point. So you could find dy dx in general first and then use substitution to find dy dx at that specific point, but I just find it at this one specific point in the calculator. So try that, tell me what you get. I think it should say 8 times 10 to the minus 2, should it not? So the derivative of x plus 3 over 2x plus 1 to the half, and okay, sorry. Okay, yeah, great. Yes, so I suppose one trick is knowing when you can't use the calculator and when you can. I suppose that might be something to it. So I just want to go to what is this one? As this is stationary point type. How would we do this one? Find the stationary point. Yeah. Would you know how to do it with a calculator? Yes, exactly. It would give you one x value, and you might have to choose a different one to get a different initial value to get a second one. Yeah, you could just graph it. 183.49. And there's only one answer, is there? Okay. Is that the full answer? Yeah. And you can try using your answer key. So I got x is 0.5. Minus 4.45. But yeah. Where's the E on your calculator? I see it. Okay. So shift graphical solve minimum. Did you put it in right? I'm getting it. X is 0.5. Y is 109. Just over X. Did I? Oh, okay. So I just use graphical solve. E to the 2x plus 3 over x. The plus 3 is in the power. So this is what it looks like on my one. And did you do draw? And did you do shift graphical solve? Yeah, in this case, minimum. I'm using the same one as you. So, you're absolutely sure it's e to the power of 2x plus 3, where 2x plus 3 is the power. I don't know. Yeah. So this is why I was saying just use graphical solve, or oh, I don't know. Okay. How do you set the thing to auto? Zoom. So shift zoom. Auto. Okay, mine looks weird. And then shift graphical solve minimum. Okay, so we have to kind of, it's based on the zoom of it. There you go. Yeah, there's no maximum. And did you get the minimum 0.5109? Yeah. That's it. Yeah. Okay, so for these, and you can always use the quotient rule. Sub in the x, do it that way. Or you can just use the graphical solve, or you can use the solver. I just want to see. I'm going backwards. So quotient rule, yep. So show that the x coordinate. So they use a show that to make you do it. Yeah, so at a turning point, dy dx is equal to 0. So find dy dx, then make it equal to 0 and solve it from there. So if it's one function divided by another, it's quotient rule. If it's one function times another, it's product rule. Yeah, how was that for you, Gregoire? So if you want, we can do differentiating the trig and stuff next. Did you want that, or did you want something else? And do you know